Hi everyone. In this session, we are going to discuss some of the important questions from the chapter Metals and Non-Metals. Important questions, set 1. Let's start the discussion. Give an example of a metal which is a liquid at room temperature, can be easily cut with a knife, is a best conductor of heat, is a poor conductor of heat. There are 4 questions and these questions are from the properties of metals. Is a liquid at room temperature. Which metal is liquid at room temperature? It's mercury. So answer is mercury. Can be easily cut with knife. There are some soft metals. So we need to write one of the soft metal. So the soft metals are sodium, potassium. These are soft metals. So answer is sodium. Is the best conductor of heat. All metals are good conductors of heat, but silver is best conductor of heat. Is a poor conductor of heat. The metal which is a poor conductor of heat, it is lead. Mercury and lead, these are poor conductor of heat. Explain the meanings of malleable and ductile. There are 2 properties, malleability and ductility. Metals are malleable and metals are ductile. So what do you mean by malleability and ductility? Metals can be beaten into thin sheet. This property is malleability. We can convert the metal into sheet. So that is malleability. Ductility means we can convert the metal into wires. We can convert the metal into thin wires. This property is ductility. So we can define now substances that can be beaten into thin sheets are called malleable substances. Substances that can be drawn into thin wires are called ductile substances. So ductility and malleability. Next question. Why is sodium kept immersed in kerosene oil? Sodium, potassium, we are keeping these metals in kerosene oil. Reason is these metals are highly reactive. They are soft metal but they are highly reactive. They will react with air. At the same time, if we are keeping it in water, it will react with water also. To avoid these reactions, we are keeping potassium and sodium under kerosene. So sodium is a highly reactive metal. It will react with water as well as air. Sodium is kept kerosene oil to prevent reactions. Samples of 4 metals A, B, C and D were taken and added to the following solutions one by one. The results obtained have been tabulated as follows. So there is a table here. In this table there are 4 metals A, B, C, D and A is adding into iron sulphate. There is no reaction. When A is adding to copper sulphate, there is displacement reaction. When we are adding B to iron sulphate, there is displacement reaction. When we are adding B to zinc sulphate, there is no reaction. When we are adding C, only silver nitrate is giving reaction. When we are adding C to iron sulphate, no reaction. When we are adding C to copper sulphate, no reaction. When we are adding C to zinc sulphate, no reaction. When we are adding C to silver nitrate, there is a reaction and D is not giving any reaction. In any of the solution, D is not giving reaction. This table is given in this question. The questions are: use the table above to answer the following questions about metals A, B, C and D. First question, which is the most reactive metal? A, B, C, D. We need to find the most reactive metal among these 4 metals. When we are observing D, you need to understand one thing. Most reactive metal will displace less reactive metal. If there is a most reactive metal in place, there will be displacement reaction. So in the case of D, there is no displacement reaction anywhere. In all boxes it is no reaction, no reaction, no reaction, no reaction. So it is least reactive element. So we are just avoiding D. What about C? In one case only we are getting displacement reaction in silver nitrate. Silver is least reactive element. Displacement reaction in silver nitrate solution is not a big deal for C. We are avoiding C and D. Among A and B, because C and D are least reactive metals. Among A and B, we are going to compare A and B. When we are adding A to iron sulphate, there is no reaction, which means A is less reactive than iron. If there is no reaction means A is less reactive. More reactive element will displace less reactive element. But in the case of B, when we are adding this B to iron sulphate, there is a reaction. So there is a displacement reaction. In all other metal, there is no reaction, but in the case of B, there is a displacement reaction when we are adding that into iron sulphate, which means B is more reactive than iron. A cannot displace iron because A is less reactive. B can displace iron because B is more reactive. So we can conclude that B is the more reactive element. What would you observe if B is added to solution of copper to sulphate? We are adding this B to copper to sulphate. When we are adding A to copper to sulphate, there is a displacement reaction. Here you can see that when we are adding this A to copper sulphate solution, there is a displacement reaction, which means if A can displace copper from copper sulphate solution, then B definitely displace copper from copper sulphate solution. So there will be displacement reaction. Arrange the metals A, B, C, D in the order of decreasing reactivity. Most reactive metal B, then A, then C, then D. So we can write the answer now. B is most reactive metal. The second question, when we are adding B to copper to sulphate, B will displace copper from copper sulphate. C, B is greater than, A is greater than, C is greater than D. So this is the answer. Which gas is produced when dilute hydrochloric acid is added to a reactive metal? Write the chemical reaction when iron reacts with dilute H₂SO4. When we are adding an acid to a metal, when we are adding an acid to a reactive metal, we are going to get hydrogen. Acid plus metal, we are getting hydrogen. In the case of dilute sulfuric acid with iron, here we are getting ferrous sulfate. We are going to write the equation. If there is a reaction between acid and metal, we are getting hydrogen, so hydrogen is the answer. The reaction is Fe plus H₂SO4 gives FeSO4 plus H2. If there is a reaction between iron and sulfuric acid, we are going to get ferrous sulfate and hydrogen. What would you observe when zinc is added to a solution of iron to sulfate? Write the chemical reaction that takes place. Here there is a reaction between zinc and iron to sulfate. So let's see the reaction. Zinc plus iron to sulfate. Zinc is more reactive than iron. So what is going to happen here? Here it is zinc, this one is FeSO4. Iron is less reactive, zinc is more reactive. So what is going to happen here? Zinc is going to replace iron. So here the reaction will be like this. The zinc is going to replace iron. This reaction is known as displacement reaction. Here you can see the products now. It is Fe alone, then zinc sulfate. Before reaction, zinc plus FeSO4. After reaction, Fe plus ZnSO4. Zn plus FeSO4 gives ZnSO4 plus Fe. Next question. Write the electron-dot structures of sodium, oxygen and magnesium. Show the formation of Na2O and MgO by the transfer of electrons. Third question. What are the ions present in these compounds? So we can solve it one by one. First question. Write the electron-dot structure of sodium, oxygen and magnesium. To write electron-dot structure, you need to know atomic number. You need to know how to write electronic configuration. So first we can write the atomic number and electronic configuration. Sodium. First one is sodium. The atomic number of sodium is 11. The symbol is Na and atomic number is 11. What will be the electronic configuration of sodium? It will be 281. Here you can see it is 281. There are 3 shells and the outermost shell is having 1 electron. 281, that is 1, means outermost shell is having 1 electron. So when we are representing sodium, you need to write Na and this 1 electron. We are just showing outermost electrons only. Here only 1 electron, so Na, this 1 electron. It is a dot structure of sodium. Next we can write the dot structure of oxygen. What is the symbol for oxygen? O. Atomic number is 8. The symbol is O and atomic number is 8. The configuration is 2, 6. In the outermost shell, how many electrons are there? There are 6 electrons. 2, 6 means there are 6 electrons. So we are going to write the dot structure. Electron dot structure will be O and there are 6 electrons. 1, 2, 3, 4, 5, 6. There are 6 electrons. It is a dot structure of oxygen. Now magnesium. The atomic number of magnesium is 12. And the configuration will be 282. Here you can see it is 282. How many electrons are there in the outermost shell? There are 2 electrons. So it will be Mg, the 2 electron, 1, 2. This is the electron dot structure of magnesium. Now we can go for the second question. This is very important. Show the formation of Na2O and MgO by the transfer of electrons. Here we need to use the electron dot structure. First we are going to show the formation of Na2O. Sodium, electron dot structure of sodium is Na with 1 electron. There are 2 Na 1 electron. And oxygen, the electron dot structure of oxygen is O, 1, 2, 3, 4, 5, 6. We are showing the electron of oxygen differently. It's a cross mark, and for sodium it is a dot. it will help you to distinguish between electrons of sodium and electrons of oxygen. These two sodium are going to donate one electron. It is an ionic bond. These two sodium are going to donate one electron to the oxygen. When you are drawing this in the exam, you need to show an arrow. Here like this, you need to show an arrow. If sodium is losing one electron, what will be the charge of sodium? Plus charge, Na plus. If an atom is losing one electron, it will be positive in charge. If an atom is getting electron, it will be negative in charge. Na plus, 2 Na plus are there. Na plus 2 and 2 electrons from sodium, 1, 2. Now octet is complete for both, and 2 minus. It is the dot structure of sodium oxide. You need to show the complete process in the exam. Now we can go for MgO, magnesium oxide. Magnesium oxide means it is MgO, and electron dot structure of Mg is Mg, and outermost shell there are 2 electrons, 1, 2. Then oxygen. In oxygen there are 6 electrons in the outermost shell, so it is the electron dot structure of oxygen, and you need to show arrow because this magnesium is going to donate these 2 electrons to the oxygen. If you know about ionic bond, you can understand completely. You need to learn ionic bond. You can use our video only and you can learn ionic bond. Okay, now we are going to donate. Now this magnesium is going to donate 2 electrons to the oxygen. You need to show an arrow. So like this you can show an arrow. After that, if magnesium is donating 2 electrons, what will be the charge of magnesium? It will be 2 plus. So it will be Mg2 plus, and oxygen, here oxygen is getting 2 electrons, it will be O2 minus. So we can write Mg2 plus in bracket and 2 electrons from magnesium, 1, 2, then 2 minus. It is the bond formation of MgO, and in the exam you need to show all the process. What are the ions present in this compound? In this compound there are ions. Na2O, what are the ions present in Na2O? It is Na plus and O2 minus. Na plus and O2 minus. Here you can see it is Na plus and O2 minus. In the case of MgO, the ions are Mg2 plus and O2 minus. Why do ionic compounds have high melting point? We already discussed about ionic compound. If you want to learn it again, you need to go through the video. The properties of ionic compound, you can watch the video again and you can learn it. Ionic compounds means the compound made by ions. There will be 2 types of ions, positive ions and negative ions. These positive and negative ions are having strong inter-ionic attraction. The attractive force is very strong. Here you can see that positive and negative, they are having strong inter-ionic attraction. The bond is very strong. So we need to give high temperature, we need to give high amount of heat to break this bond. That is the reason for this high melting point, due to strong inter-ionic attractions. Define the following terms: mineral, ore and gangue. The elements or compound which are naturally available on the earth crust are known as mineral. The metals, we are getting metals from the earth crust and ocean in the form of compound. We are separating the metal from the ore. So ore, the mineral is the compound of metal found on the earth crust or ocean. These are minerals. If the separation of metal from a mineral is very easy and profitable, that will be ore. So we can define ore. It is a mineral from which metals can easily and profitably extract. The mineral from which a metal can be easily and profitably extracted is called ore. And what about gangue? Gangue means when we are taking ore from the earth crust, it will be consist of impurities. These impurities are known as gangue. The impurities present in the ore are known as gangue. Name 2 metals which are found in nature in free state. The metals which are found in free state, it is platinum, gold, silver. Gold, silver and platinum. These are noble metal, least reactive. These metals are present at the bottom of activity series. What chemical process is used for obtaining a metal from its oxide? Here there is a metal oxide. From this metal oxide, we need to get metal. Metal oxide gives metal. The oxygen, we are removing oxygen from this metal oxide. Removal of oxygen is reduction. It is removal of oxygen, the process is reduction. So we can write the answer. The process is reduction. Metallic oxides of zinc, magnesium and copper were heated with the following metals: zinc oxide, magnesium oxide, copper oxide. The metals are zinc, magnesium, copper. In which cases you will find displacement reaction taking place? It's a very easy question. You need to understand one thing: more reactive element displaces less reactive element. That's important point. More reactive element will displace less reactive element. First we need to understand which is more reactive and which is less reactive. For that you need to go through activity series. It is our activity series. You can see the activity series here, starting from potassium and ending with gold. Here we need to consider only 3 metals: zinc, magnesium, copper. So all other metal we are going to avoid all other metal now. Only we are considering zinc, magnesium, copper. In this metal, which one is more reactive? Magnesium is more reactive because it is at the top, and copper is less reactive because it is at the bottom. Zinc oxide. Zinc oxide, when we are heating zinc oxide with zinc, both are same metal, so there won't be any reaction, so we can write no reaction. And zinc oxide, magnesium, zinc oxide with magnesium. In this case, we need to compare the reactivity of magnesium and zinc. Which is more reactive, magnesium or zinc? In the list, which one is more reactive? Magnesium is more reactive. So magnesium can displace zinc from zinc oxide. So there will be displacement reaction. Next one, zinc oxide with copper. Which one is more reactive, copper or zinc? Here copper is at bottom and zinc is at the middle. Means compared to copper, zinc is more reactive. So there won't be any reaction. It is no reaction. Next one, magnesium oxide and zinc. Magnesium oxide and zinc. Which is more reactive? Magnesium is at the top. Magnesium is most reactive, so there is no reaction. Second one, next one, magnesium oxide and magnesium. Magnesium oxide and magnesium both are same metal, no reaction. Magnesium oxide and copper. Magnesium is at the top. So magnesium is at the top means from the magnesium oxide no one can displace magnesium. No reaction. Copper oxide. Copper oxide and zinc. Copper is least reactive at the bottom. So all the metals, magnesium and zinc, can displace copper. Means when we are heating copper oxide with zinc, there will be displacement reaction. When we are heating copper oxide with magnesium, there will be displacement reaction. When we are heating copper oxide with copper, no reaction because both are same metal. Which metals do not corrode easily? The metals present at the bottom of activity series, they won't corrode easily. Corrosion means chemical destruction. Metals at the bottom of activity series, gold and silver, they are not reactive. They won't corrode easily. What are alloys? Alloys means it is a mixture of homogeneous mixture of metals and non-metals. It can be metal plus metal or metal plus non-metal. An alloy is a homogeneous mixture of two or more metals or a metal and a non-metal. If you like this video, subscribe to my channel, visit our website www.winpointonlineclasses.com. Support us for providing free online classes to everyone. You can always ask your doubt using comment box and share this video. Thanks for watching.